Okay, so the main point of me doing this is I'm planning to start a YouTube channel, teach people like what I've learned during this course, and what's better than teaching a live group than to have just like a regular video. So that's why like I'm doing this. Um, so today we're going to talk about async task loaders, and I get a lot of on the group chat on the Slack channel. There are many people who are confused about it, and hopefully this video will sort of address those issues. So firstly, before we start talking about the async task loaders, let's talk about why we need task loaders, right? So there is a thing on your app that's called the main thread or the UI thread. And the UI thread it's a default thread that your phone provides to your phone that runs all your operations, right? So a thread is like a place where execution of blocks of code is happening, and it is very important to understand and to be cautious about that. This thread should always be running as smoothly as possible. Okay. So it is really important to make sure that the main thread only contains quick and easy operations, right? So anything that's mainly UI related, you don't want to run anything that's like fetching data off the internet or modeling a huge rendering something that's very huge, like a big image, for example. So let's imagine that you are having this big task, like rendering this 3D awesome model, right? So it's gonna block your UI thread, and the other task that's behind this big task will not run until the big task is done. So essentially, what will happen is that your UI won't be responsive. So the user can tap anywhere, but nothing is happening. So at that point, the user will uninstall your app and give you a 1-star rating, right? So this is a very bad practice. So instead of doing everything off the main thread, why not do it on another thread, right? Or better yet, maybe there's a library in the Android SDK that can manage all these threading complications, because as a developer, you don't need to worry about the low-level stuff like the threading, like managing the thread deadlocks and things like that. Android has a library for you that's called the AsyncTaskLoader, right? So at the AsyncTaskLoader on the low level, if you're just talking about Java, it's just basically a neat wrapper. Okay, so AsyncTaskLoader is just basically a neat wrapper over the thread class. Okay, and also, of course, it also ties with the Android activity lifecycle, right? So that's the main difference between AsyncTask and AsyncTaskLoaders, is because it's the fact that AsyncTaskLoaders, they tie to the activity lifecycle, right? And we'll talk about that more on the later slides. So back to the slide, the AsyncTaskLoader helps developers to dispatch tasks to another thread by using callbacks and loaders, right? Now, what is so special about AsyncTaskLoaders is that they are attached to the activity's main lifecycle. And you can actually see that because whenever you create a loader, which we'll see later on in a minute, is that you actually need to pass an activity inside of that loader. And the reason for that is that you need to satisfy the super. So when you create a constructor for those loaders, you gotta put in the context, and you have to go super context, so super and then parentheses context. So that's how the loader knows which lifecycle I should bind to, right? Um, so let's look at lifecycle and AsyncTask. So let's say you call up your friend, right? Now this is relating back to real world stuff. It's like, hey bro, can you go online and check what time the Stranger Thing is on tonight? My internet is broken. So right. So if I'm calling you up, Richard, and I said that, hey, my internet is broken. Can you check something for me? And say, yeah, sure. So I would hang up and wait and wait and wait, and you call me back and say, hey, yeah, it starts at 8:30 or something. So let's dig a little deeper, right? So let's say that he's Cartman, Kyle. So Cartman is kind of like the main thread, right? So I'm delegating a certain task to Kyle, the background thread, and say, hey bro, can you check something for me? My internet is broken. Right now, in the real world, Kyle would expect. So when Kyle finishes finding out what time the show starts, he would expect that Cartman is still around, right? He's just not going to vanish out of thin air. He will still be there, and ready to deliver the results back to Cartman. So in the real world, if you ask someone to do something for you, you would expect the person to hand you back that job, right? You would expect that they're still around. I mean, the chance of them vanishing is pretty abysmal. So therefore, Kyle would expect Cartman to be around, since Kyle finished with the task and he can tell Cartman the time. So why would this be important? Well, if you look at the async task, the course, when they introduced sort of like the threading part, they started with the async task and then the AsyncTaskLoader. So what the AsyncTaskLoader trying to solve is this. So you're on your main UI thread and say, hey, go render this cool looking model for me. And the background said, hey, cool, yeah, but don't go around. Don't go anywhere until I'm done. I'm holding on to you, right? So in object-oriented programming, whenever you have object or instance of an object that equals to each other, like if they have references to each other, sometimes it's a bad idea. And if one instance have a strong reference to another instance, that instance isn't going to be garbage collected. Okay, that's the main problem with the async task, is because when your activity is rotated, or when the user terminates the program at once, the AsyncTaskLoader still has a reference to your main activity, or wherever it's prompted at, right? So you cannot that background task cannot be garbage collected. And what's worse is that if you open up your activity again, that means the async task will run again, right? So you're gonna have that. That's why they say it's you have this zombie activity. It's because it's holding on to a phantom object, right? And that phantom object isn't going to be garbage collected. So if you do this dozens of times, your app will just crash out of nowhere, because your application is creating a lot of memory pressure on the user's phone, and I mean, you don't have the authority to keep your app running, right? It's the Android in the background that determines which app gets terminated. So back to this slide. I'm rendering, and what if at this point in time, what if the user completely shuts off the app, right? So so this goes to from a red to a gray. So it's rendering, and it say, okay, I'm done. But where should I deliver this result to? I'm holding on this zombie object, and I'm not letting go, because I have a strong reference. I have a strong reference to the main thread, and so the background thread had a strong reference to the main thread. Therefore, this thing isn't going to be garbage collected. It's not going to be garbage collected, which means that you're going to build incrementally. You're going to build a lot of memory pressure on the user's phone, and the OS in the background will terminate your application when the certain threshold of that pressure is met, right? So the background doesn't know the activity that's being called task has died. However, the background thread is holding on to a zombie version of this activity. This is a problem because it causes extra memory pressure on your phone, reduced battery life, and results in a one-star review, which you don't want. So in short, AsyncTaskLoader is attached to the activity's lifecycle. So that means that it's not going to attach it to the main thread if the main thread is not in memory, right? So let me go back to this for a second. Actually, this is very important. Now I came from a Swift background. I used to do a lot of programming on iOS, and it is very easy for you to. Okay, let's back up for a moment. If the background thread has a reference to the main thread, that means I have a strong reference. It's called a strong reference, right? And also, obviously, the main thread has a strong reference to the background thread. Now, the main problem with the strong reference is that so imagine this is the UI thread or the main thread, and this is the background thread. If both of them had the same reference, if this guy goes away, this guy will still keep its reference because it's a strong reference. Now, there are two ways you can solve this problem. One solution is that you can have from a UI main thread to the background thread, you can have a strong reference to it, but you can have a weak reference from the background to the main thread. So what that does is that if the UI thread or the main thread disappears, that reference will be canceled. It will be annihilated. So this reference will be annihilated, right? Now, there's another way. It's called a unowned reference. Unowned. So what does that mean? It means that if the UI thread or the main thread has strong reference to the background thread can have an unowned reference to the main thread. And what that does is that if the main thread gets out of memory, this also gets out of memory. Okay? So there's two differences. If I have a weak reference, this guy will still be around, but it doesn't hold any reference. If this guy has an unowned reference to the main thread, this guy will get disappeared too. So for an unknown reference, this guy will never outlive this guy. That's the main difference. If it is a weak reference, this guy can outlive this guy, but this guy cannot get a reference to this guy. Okay, so that's the main difference. So the major problem with AsyncTaskLoader is that this guy has a strong reference to this guy, which means that if this guy gets out of memory, this guy still clings on to this object, which makes this guy unable to be garbage collected. So let's have a look at the code, right? So at 10,000 feet, we have, okay, so what do we have here? Okay, so you are wanting to execute a task on the background thread so that your UI thread isn't blocked by some huge task, right? You always want to make your UI thread clean and responsive. Okay, so you have your activity, and then you have your async task loader, and we're gonna talk about what's happening in between this membrane here, or this interface. Okay, so at 10,000 feet, at 10,000 feet, you have something called a loader manager, right? So loader manager is just like any other manager in real life. They manages people, right? So, but instead of people, they manage loaders, and instead of naming them with names like George, Bob, Steve, Carol, Stephen, they have IDs. Okay, so it's probably back in this industrial age where they don't go by names, right? They go by IDs or something. Um, so you have loader 1, 2, 3, 4, 5, 6, 7, 8, 9, or something like that. Okay, now and you got this background task here, right? And this guy can go off and say, "Hey, rendering this," okay, and this guy can go off and render this. What I'm trying to show here is that in an activity, although it might not be a good practice, you can have several loaders working for you, and these loaders are managed by this loader manager. Okay, so you don't actually how do you say it? You don't actually own the loaders. The manager oversees those loaders, and the manager, the manager and your activity, they communicate. Okay, the manager and the activity, they communicate, not the loader and the activity. The loader and the activity doesn't communicate together. You only communicate with the loader manager and your activity. Okay, and you do that with a callback. So when they're done, they will tell the boss, say, "Hey, I'm done," and this boss here, this manager, will tell you that it's done, and then what do you want to do with that new data, right? So to create a loader, you have a class. So it is a class that extends from AsyncTaskLoader. And this AsyncTaskLoader is a generic type, right? So what is a generic type? So a generic type has a parameter type with this by this angular parentheses, and the D represents any type that you want this to. So this defines the type that is returned, right? So, for example, if you want to fetch data off the internet, D would be your parameter type. Oh, sorry, string will be your parameter type because you're parsing a JSON or fetching a JSON, right? But this could be a custom type. For example, if you have a 3D model, you can put in I don't know, 3D model type here. So this parameter type signifies the return type of the finished product. Okay, this is the return type of the finishing product. So the loader has several key methods that you need to define. Firstly is the override on start loading, right? So what this does is before I go to work, what do you want me to check? So it is very wise to create a loader that has a cached memory, right? So let's say you are building a weather app, for example, and so you would have a cache memory inside of it's kind of like a member property that has the latest JSON file, so that when you go on start loading, you can check to see if the data is present. If the data is present, then jump straight to deliver results. If not, I'm going to start loading it. So this is the place where it checks Okay, this is checking to see if I have a cache memory or not. If I have the cache memory, then deliver the result. If not, then load in background. So let's jump to it one by one. So the next one, load in background. What do you want me to do in the background? So, of course, this if you're fetching data off the internet, this is where the networking part comes in, right? And on deliver results here will give you a string type of data because I have specified a string here, right? So this will correspond to whatever the parameter type that you specify for this loader, the weather loader, right? So the parameter type that you define in the class declaration, this will be corresponded to the parameter type. I'm sorry, the method parameter in the deliver results. Okay. So the manager, you can think of it as the voice of the loaders, right? So to create a loader manager, you actually have to implement the loader callback. So the loader callback has three main features or three main methods. You can have more. You can check out the documentation, but there's more. So for example, if you want to know if the loader stopped loading, you can have an on stop loader callback, right? So when the loader stops, that method gets called. So on create loader, it returns a type of loader, which makes sense because we're creating a loader. So this essentially is saying, okay, order from the boss, loader ID 512, here's your work, here's your data, go to work. And then on finish, on load finish, this will get called whenever a loader has finished its task and it's coming back. So it's like this, right? So on deliver, so this method gets called, and then this will get called. This will get called, okay? Because I'm delivering the results back to the manager, okay? So it's in that sequence. So deliver results from the loader, and then this onload finish method will get called. And the loader reset is just basically if the user refreshes the page, this can get called, right? So this loader manager, the one problem with that is that if you have a multiple loader that does several things, so like so one loader gets JSON files and the other loader he gets modeling some complex 3D model or something, that this would be a type of object, because you cannot define a concrete type for this, right? Because multiple loaders returns multiple types of objects, right? And this, now I'm not sure if that's the way to do it, but there's several problems with that is that you would have to cast a lot of types, and casting often it's a very bad, well, not very bad, it's not a good practice. So in summary, loaders communicates with the loader manager, and the loader manager communicates with your phone or your activity. And you see a lot of this pattern sprinkle around in the Android framework. Because think of your activity, it's like your application layer, right? It's what's being seen by the user, right? So it's the application layer. Now, to make your application happen, you have tasks that you create, right? So for example, I have network utils, I have render 3D model, I have lots of other custom types that I've defined to make the application layer work. One of the the architecture of the the application layer is very crucial, and for the application layer to interact with all the stuff that you've created, it should always through an interface, just like how you have loader manager added to your application layer. You always have a layer in between the classes, because that's decoupling that's the way to decouple the application layer to all the nitty-gritty classes that you have defined and created, right? So this is a very common pattern, and I have several links down here where you can get a more insight. It's a very useful source of information. So let me jump ahead and go to a demo. By the way, do you guys have any questions at all that you want to ask me?
Yeah, I had one. Is there any time that you would use an async task without an async task loader? Or is that just a stepping stone for instructional purposes?
There would be a time where you want to have an async task is if you want to quickly go and check to see. So for example, you have this production app, and you want to check whether the version is correct or not. Well, you wouldn't really need to have a loader, right? Because checking it's very quick. I mean, of course, you can go all the way down to the loaders, but from what I gather from another talk that I was involved with, that's a typical way that you would use an async task, is to just have a real quick check on versions of your application.
Okay. Gotcha. So async task is blocking then.
Yeah, I'm not actually sure about that one. It could be because unless it's really quick. But if I was the one who is making that feature or something, I would just go all the way loaders, like, because you wouldn't want to build up that memory pressure on the phone, right? What if the internet is really slow? Like, there could be a possibility that that the thread is clinging onto that activity and isn't going to be garbage collected. So if you do that multiple times, your app will just terminate while the user is using it. Like, it looks fine, but because of that background that is happening, it's not going to be garbage collected, which is a bad thing.
Gotcha.
Yeah. Okay, so let's create some code here. So let's say that I'm creating a loader, right? So by the way, loaders, if you're creating a loader in an activity, it has to be static. Now, the reason why it has to be static is because you wouldn't want to create a instance of your main activity and then create your loader, because essentially if you don't make it static, that means that your loader always has a reference to your main activity, which you don't want, right? That dependency comes from, and I mean dependency is letting the loader know what lifecycle do I need to watch for. You do that in the constructor of your loader. So let me show you this. I've got some code here. So okay, so public static class, and I'm just gonna say loader 1.
Brandon, it looks like we're still seeing the PowerPoint.
Oh,
we can't see
okay.
the code.
Sorry.
No worries.
Okay, can you guys see the code?
Nope, just a white line.
Okay. What about now?
Yep.
Okay, so let me make the text bigger. Hold on. Fonts. Let's make it 20. Okay, is it big enough? Is the code big enough?
Yep.
Okay, sweet. So let's just call this loader 1, and I'm gonna extend this. Extends async task loader, and I'm going to have a return type of my deliver results type string, right? So first of all, I need to override on start loading. And the second one I need to do is on, oh no, load in background. Load. And yeah, load in background, and I'm gonna have deliver results. Okay. Now it is, the reason I'm having an error is because I don't have a constructor. So let me do this constructor thing. So public loader 1, and I'm going to have a parameter of type context. Now the reason why I need to have a context is it's only to satisfy my super. So super context. Now this line here is very important, because without this line, this loader doesn't know. So this line is very important because this line tells the loader which context do I need to look for, which means that which life cycle should I be aware of, okay? So whenever you create this loader, you got to give it the context. So the super knows that which activity I need to watch out for. Okay, so let's have another parameter of type string, and I'm just gonna call it data or something. Yeah, it's got data, and I'm gonna say string and data. So, and I'm gonna initialize this. So, so this dot in data is equals to that. Now, what this is doing is just I'm caching in. So this is where the caching part happens, right? So whenever I have a finished product, right, I will want to cache it so that in here, let me make this better. So that in here, I can do this. I can say, hey, if end data is not equals to null, then start loading it. Oh, it's not equals to null, no. Then this would be deliver results. And I'm going to pass in the data. So this guy, this results, deliver results, call this guy. And this is very important. This guy calls this guy so that, I haven't coded in yet, but the reason why it's important is because this guy prompts the on load finish on your loader manager. So this line is important to know, okay? So this line prompts this line, and then from this line, it prompts the loader managers to say to the activity, hey, I'm done. What do you want to do with that, okay? So if my data is null, which is else, then I'm going to say start loading. Start loading just prompts this guy. Okay. Now, there's a difference. I know that in the Udacity video, they have force loading. Now, force loading, I should really use force load. Oh, well, but it actually doesn't matter. So the difference is that in force loading, it doesn't care if you have any data. So it doesn't care if you have any cache data in hand. It will just force it to load. Start loading, on the other hand, to my knowledge, it checks for the memory to see if the loader has any data or not. But I'm not too sure on that. So actually, it's best to use force loading because we did the check here. So we're just gonna say force loading. Okay, so in here, I'm just gonna say return hi, I am loader 1, and I am processing this data, which is this end data here. Okay, it's okay if this doesn't make sense. All I'm trying to show is that how you would build an activity with multiple loaders, right? So on deliver results, we're just gonna call it and that's it. So on your main activity here, I'm gonna create my manager, right? I need that manager. So loader manager, and now because I have multiple loaders that could potentially deliver multiple types of return types, right? So here you can't say string, right? Because what if my second loader returns an integer or a double value, or something like a student type, customer type? You can't put a string here, right? What you can do is that you put an object. And I'm not sure if this is a good architecture or a good practice, because from what I've learned, casting objects is a very bad idea. The reason why it's a bad idea is because there's a difference between getting an error during compile time and getting an error at runtime. Now, if you do that, and if you cast it to a wrong type, you get a runtime exception. Now, you never want to have an exception, because if you have an exception, that means that this product is already out to the user's hand, and the only way that exception will get captured is when the user does something very specific to make that exception happen. So by that time, it's out to production. You cannot pull it back or anything. I mean, you can update with a patch or something, but you never ever want to have typecast, well, as minimal as possible, to avoid runtime exceptions, right? So, but in this case, we'll just go with this. So let's implement my parameters. I mean, my override methods. So this is the manager part, okay? So, oops. Now, is this all making sense, guys? Do you want me to explain something else, or? Hello?
Yeah, I think it's making sense.
Okay, cool. Okay, so this is the loader manager. So I'm gonna say in here, I'm gonna return this loader manager. So new loader one. I'm going to type in the context, and I'm going to pass in a string. So complex string. Okay, so why is this? Require loader. Okay, hold on. Oh, hold on a second. Okay, we'll just continue. I think this looks fine to me. Okay, so on load finish, I'm just gonna say, hold on, let's create some IDs here. So public static final loader one. Now loader always needs an ID, so ID equals to 100. So if I have a multiple loaders, I will need to do this. So switch loader dot get ID. So case, so if I have a loader one, and I'm just going to print out the toast, create a toast. I'm going to say data to string. I'm just going to make this long. Okay, never mind. Oh, here, length, not long. Okay. So if you have another type of loader, you would just go like this. Let's say you have another loader here. And you can make this 200, and then you can do this. Case loader 2, and then you can just do something, right? So do something. So let's just quickly have, let's just quickly build some UIs here. Okay. So I'm going to do this. I'm going to have a linear layout. Okay, and I'm just going to have 3 buttons. So button, wrap content, and I'm going to say ID loader 1 button. Here I'm going to go button. ID loader 2 button. And here I'm going to say loader 1 text loader 2. So let me just check. Okay, that's fine. So I can go back to here and I can say button, loader 1 button, loader 2 button. Oops. Okay, so first thing I need to do is that I need to bind this, right? So I can go loader 1 button equals find view by ID r.id dot loader button 1, loader 2 button find view by ID r.id dot loader 2. Okay, so right now what I can do here is let's see, let's have a look. So okay, so the main point of this loader is to just basically take whatever I give it, which is the data part, and then I'm just going to say, hi, I'm loader 1, I'm processing this data, which is the M data. Okay, so loader loader 1 button dot set onClick listener, and I'm going to have a new view onClick view. Okay. And then right here, I'm going to tell the manager to load a loader for me. So I'm going to have a loader ID, which is the loader 1. I'm not going to pass in any bundles. And I'm going to pass in the callback, which is this. Init loader. Yes. So you would have another one that goes like this, right? Unclick. OnClick. So you would do something like get loader manager init loader, and then you give it the ID, the bundle. So ID, the bundle, and where the callback is, So in this case, it will be in this class, right? Because I am implementing the loader. But what you can do is, and here's a trick. Here's a very neat part, is that if you have multiple return objects, what you can do is just create a custom callback. You can do this even, like loader manager the loader callback. And then, for example, this could be an integer. And then you say new loader, this one, int, and then you just specify what you want to do, right? So int type callback, and then you can just specify what you want to do here, so that in here you can pass in this thing here. Does that make sense? So there's a lot of options that you can go, but in this example, if you go by this example, you will need to cast it. So you will need to cast to the corresponding type inside your on deliver results. But if you do it in this way, what it will do is you won't have the type casting issue because you define the type here already. and then you can create a lot of these, right? You can do this multiple times even. Right? It could be customer type, or this could be a student type, and then during these on-click listeners, you can do that, right? You can go. Let's say this is customer type callback, customer, and this is a student type callback. Student type callback. And you can say, let's say this is loader number 4 or something, and then you can go like
data update.
Student type callback. Does it make sense? You can add flexibility by doing this, and you don't have to cast, or you can just do one big loader manager at the top, but you have to cast it. Okay, so whichever works for you. So let's just go back to this. So this is loader 1, and this is this, or main activity.this. Sweet. So now what's happening here? Extends. Okay. Hold on, guys. On the loader. Okay, I'm running this purely off of memory. At the same time, I'm reading the code that I got from last night when I'm preparing for this. So just bear with me. Oh, context. Oh, okay. Context. Oh, okay. Well, actually, I need to do this. Because here, I need to check which loader gets loaded, right? So switch, again, ID. So if the loader is loader number 1, then I go return new loader. I'm going to pass in this and some complex string. That's right. Got it. Okay. So this is a loader type. Oh, okay. Okay. I'll need to cast this. Oh no. Oh, okay. The other side. Oh, I know where the problem is. The problem is this guy here. It's a type of string, and I'm expecting a type of object. So what did I do yesterday? Okay, well, let's just make this. Okay, I'll just need to cast this. So, okay, so on finish. Yeah, so you will need to just remember it. So async task loader object, although it returns a string, right? But you still have to do it as an object because your main callback is an object. So actually, by doing this way, it's very bad because there's a lot of casting going on. What's happening here? Okay. Some more errors. Wow, this is okay. So I need to provide a default case. Return null. And then in here, where is oh, is that it? Okay. Now let's run this and see what happens. So actually, I was strongly against doing it this way because if you have just like a generic type of object, then all of your loaders will need to be typecasted, and typecasting is very bad because whatever happens, like bad thing happens, it happens on an exception level, which is the runtime level. So very bad. So I would highly against doing this. Instead of doing this, you can do what I just did, which is the loader manager .loader callback, loader callback, and then you have like a custom class, and then that equals to, or okay, I need to put a name. So a name of your callback, and then blah blah blah, blah blah blah, and then in here you can use this name, and then you put it in here. Okay, and then if you have a second loader, you can put another loader manager in here, right? Okay. I'm not sure why. Whenever I have the zoom on, this runs very slowly. It's not even responding to me. But yeah, I have a full demo code ready, and I'll post it up on Slack so you guys can have a look at it. And feedbacks are welcome. If you don't like the architecture or the pattern that I'm using, let me know and why, so I can know as well. But if you guys have any more questions, then fire ahead. But if you guys don't, then yeah. So do you guys have any questions or? Hello, do you guys have any questions?
I'm probably going to have questions. I might just ping you because I'm going to have to think about it.
Okay.
I'll probably watch the video over again and
Cool.
questions.
This is recorded, so I will post this on the YouTube channel, and then everybody can watch this. Also, I'm gonna put the demo code that I had yesterday, which is less disastrous, and I'll post that on Slack as well. So you guys can look at that. So okay, thank you guys for coming in. Feedbacks are welcome, of course. I'm still learning this together with you guys, and yeah, feedbacks are welcome. Okay, so that's all for me, and yeah. So if you guys have any questions at all, just DM me. My Slack channel name is Aleph. That's ALEPH. And I'm on pretty much all the time. So thank you guys for watching, and yeah, DM me if you have any questions, and see you guys later.
Thank you.
Thank you.
Thanks.